In this video, we're going to review how to compile the data and to present the data in a very organized and succinct manner when it comes to using the analysis of variance approach. So if we have a research design that requires the use of analysis of variance, and we've completed all of our calculations, those calculations should be compiled into an ANOVA table, and this is a standard way of presenting the outcome of this type of statistical procedure. So on the left-hand side, you see we have our sources of variation, our between source, our within, and our total. And we begin by first indicating the data, our first stage calculations of our sum of squares. And so we indicate that separately for the between, within, and total terms. Of course, the total term is just simply adding up vertically of the between and within. Now, when we take a look at the sum of squares, these two values appear to be quite similar. There isn't a great deal of difference, indicating that the variation might be similar between these two sources, and we cannot say that until we consider the degrees of freedom. And so we have our between degrees of freedom, what we had calculated earlier. That goes into the next column with our within and our total, once again, which is adding up vertically between the between and within terms. Now you'll notice when we move to the next columns, we have our mean square, our calculated F value, and a P value. But you have these cells that are empty, and we keep these cells empty. For the mean square, we could calculate a total mean square, but in terms of interpreting the data, this value would be meaningless to us, so we don't bother calculating it. We just leave that cell empty. So we see that once we consider the degrees of freedom, as we did in the previous video, we have a much larger variance for our between term than we do for our within, and that led us to an F obtained of 7.99. The p-value is obtained from a computer program where the value here indicates the probability that we are making a mistake in our conclusions, a type 1 error. And you can see here the risk of committing a type 1 error is 1/10 of 1% here at less than 0.001. So that gives us a great deal of confidence in being able to say that there is a statistically significant difference somewhere between those five groups. And once again, as our F obtained is larger than our critical F value, then that leads us to reject the null hypothesis. And we would conclude that there is a statistically significant difference in new locations between those five different business sectors. So to revisit our example and our research question, is there a statistical difference between the different sectors of the economy for the number of new locations opened in 2023? And we would conclude that yes, based upon the overall ANOVA results, there is a statistically significant difference. Now at this point, we would revisit the descriptive data, which is the mean plus minus the standard deviation for each of those five groups, and we can see that the cannabis retailer average is the largest one and the restaurant average is the lowest one. But the overall question here that we are left with is that we know that there is a statistically significant difference in here somewhere, but we don't know precisely which of these are statistically different than the other. We cannot just look at the averages and conclude that these are all statistically different. Recall that back when we indicated the alternative hypotheses, there were a large combination of those, and zeroing in on which one is the one to go with depends upon the next level analysis, which is called post hoc testing. So in the event that we reject the null hypothesis in the application of analysis of variance, that requires us to move to the next step of conducting post hoc analyses. If our statistical results, if the F obtained was not greater than the critical value, so we found in our study here it was greater, but suppose that the F obtained was a value of 2.0, which was less than 2.69, then we would not reject the null hypothesis, and we would state that there appears to be no statistical differences between the 5 groups. And then that's where the analysis would stop. We would not do a post hoc analysis if that were the situation. But our current situation is that there is a significant, statistically significant difference, but we can't state which one yet. So in the next video, we'll cover how to carry out post hoc testing.